I am Taruka Sandarayanu. My registration number is 4191. In this presentation, I will demonstrate a criminal investigation data pipeline built using Apache NiFi. The problem I have chosen is criminal investigation data management. Police departments worldwide receive thousands of crime reports daily from multiple sources containing vital information about crime type, location, suspect details, and case status. There are 4 key challenges. First, manual sorting means officers waste hours organizing records instead of investigating. Second, violent crimes get mixed with minor offenses causing delayed response. Third, manual processing causes data errors and misclassification. Fourth, the system cannot scale as crime data volumes keep growing. This is exactly kind of real world problem that Apache NiFi is designed to solve. My solution is an automated criminal investigation data pipeline built using Apache NiFi. As you can see on this slide, the pipeline has 7 processes working together. Data flows from left to right. It starts by fetching crime data from the UK Police API, then splits the data into individual records, then validates each record, then extracts key fields, then adds metadata, then routes each crime into correct category. The output is 8 organized folders: violent crimes, robbery, drugs, burglary, vehicle crimes, antisocial behavior, and other crimes and rejected records. The key design principle is separation of concerns. Each processor has one specific job. Now let me switch to Apache NiFi, where I have built this pipeline. Here you can see the complete data flow on the NiFi canvas. All 7 processors are connected together with arrows showing the direction of data movement. Starting from the top left, invoke HTTP fetches data from the UK Police API. It passes to split JSON, which splits records. Then to validate data, which checks each record. Then evaluate JSON path, extracts the fields, then update attribute, adds metadata, then route on attribute, categorize each crime. Finally, the data reaches the put file processors, which save files to correct output folders. This is a clean and organized pipeline. Each processor has one job and passes data to the next. Now let me start the pipeline and show you how data flows through it. I will start all processes now. You can see the numbers on each processor is starting to increase. This shows data is actively moving through the pipeline. Invoke HTTP has fetched data from the API. You can see the queue between processors filling up and emptying as data moves forward. Split JSON has split the API response into individual crime records. Validate data is routing valid records forward. Evaluate JSON path is extracting fields from each record. Update attribute is adding metadata. Route on attribute is categorizing and routing each crime to the correct put file processor. The pipeline is fully running. Data is being processed automatically without any human invention. Now let me stop the flow and walk you through each processor in detail, showing you exactly how I configured them. Invoke HTTP is the entry point. Here you can see the URL is configured to the UK Police API with real London coordinates. Method is get. I chose this processor because it supports scheduled execution, automatically fetching data without any manual trigger. Split JSON breaks the API array into individual flow files, one per crime record. This is a critical design decision, enabling each crime to be processed independently. Validate data is a route on attribute processor used for data validation. Valid records move forward, invalid records route to the rejected folder. This ensures bad data never enters the main pipeline. Data quality is critical in investigation systems. Evaluate JSON path extracts 3 key fields from each crime record. Crime category means the type of crime. Crime location means the exact street name. Crime outcome means the investigation status. These become flow file attributes used by downstream processor for routing decisions. Next, update attribute. It is my data transformation step. A dynamic file name is generated combining crime category and timestamp, making every file uniquely identifiable. A processing timestamp and case status of processed are also added, giving each record full audit information. Next, route on attribute. This is the most important processor, the intelligence of the pipeline. I have defined 6 routing rules using NiFi expression language: violent crime, robbery, drugs, burglary, vehicle crime, and antisocial behavior. Each has a dedicated route connected to its own put file processor and output folder. Any unmatched record automatically goes to the other crimes. This design is easily scalable. Adding a new crime category only requires adding one new route and one new folder. Now let me show you the output results of the pipeline. Here in the File Explorer, you can see all the output folders that were automatically created and populated by the pipeline. Violent crimes folder, files saved here automatically. Robbery folder, files here. Drugs, burglary, vehicle crimes, antisocial behavior. Each crime type has its own dedicated folder with files correctly categorized. Let me open one file to show the actual crime data inside. Here you can see a real crime record from London. The crime category, street location, and outcome status have all been correctly extracted. The file name includes the crime type and timestamp. The case status shows processed. This is exactly what the pipeline produces: organized, enriched, and correctly categorized crime data, all done automatically. To conclude, this Apache NiFi pipeline successfully solves the real-world problem of manually sorting crime data. The pipeline fetches real crime data from the UK Police API, validates every record to ensure data quality, transforms each record with meaningful metadata, and automatically routes it into the correct category folder. What would take officers hours to sort manually now happens automatically without any human invention. The key feature of my design are data validation and error handling, data transformation and enrichment, intelligent routing using NiFi expression language, and a scalable architecture that can easily handle thousands of records. This demonstrates how Apache NiFi can be used to solve real-world data flow challenges in professional and efficient way. Thank you.